Hey, hello everyone. Today we are again back with another question from LeetCode, and we'll be discussing this question, which whose simple solution is or iterative solution is very straightforward, and but the optimized solution gets quite tricky. So we'll directly jump to the description. So I'll explain you what exactly is the question. The question here is like we have been given a heights array or list which has certain integers in that. So those integers are basically the heights of building. So for example, height of 0th building is 6, then 4, then 8, then 5, then 2, then 7. So and similarly, we have been given a queries array as well. So what does this query do? Query has list of list, or we can say 2D array, which has two numbers, two integers which are indexes. So on the first index, let's say 0, we have one person standing whose name is Alice, and on the second index 1, we have another person standing whose name is Bob. So what happens is they both can move right. Either of them can also move right, or they both can move right, and they have to meet at a certain building. And the criteria to move right is that the height of the building where someone moves should be greater than the current building. So, for example, we have 6, 4, 8, 2, and so on in the example itself. So, for the first query, we have 0, 1. So, Alice is here, Bob is here, 0th index is for Alice, and first index is for Bob. They can move right, and they have to meet. So, if Alice could have moved right, like let's say if it was 7 over here, Alice could have moved right and they would have met where Bob is himself. Like they could have met at the first building itself. Uh, but since the height of the first building is 4, which is smaller than 6, that's why 6 cannot move here. And 4 uh, has also to needs also to move right. So 4 will move here. So they both can meet at this index. That is 2, not 1, 2. So we'll have an answer list whose first answer would be 2. Similarly, let's take another example. So we have 0, 3. So 6, 4, 8. We have a 5 over here. So 1, 2, 3. So, so first person is at 0, the second person is at 3. So 6 and 5. So 6 cannot go to 5 because they are for the height 5 is smaller than 6, so they have to find another element which is on the right of these both and have a height of higher than both. So it is 7. If we go to the example and we see after 2 we have 7, and so the answer is, since the index of 7 is 5, the answer becomes 5. So on and so forth. So we can understand two things. Like let's say if the query had 3 and 5, like first person is at 5, second person is 7. Similarly, Alice could move to this building because that person moved right. So he moved to this building, and Bob need not to move anywhere because they can meet at this particular building. So answer would have become 5 if the query was 3, 5. So I'm just giving an example that just one person can also move. So similarly, let's say if both the queries have 2, 2. So both the person are at the same index, that is 8 and that is 2, and the height is 8. So the answer simply becomes 2 itself because they are anyways at the same building, so they don't need to meet, and the building where they have already met is 2. So this is a simple question. Now the iterative solution is to this question is quite straightforward. I guess and I hope that anyone who is attempting a hard question will be aware of the iterative solution or will be able to figure it out immediately. So what I'm doing here is again 6, 4, 8, 5, 2, 7. So iterative solution is like if the height of the right building is greater, then its index becomes the answer. If the height of the right building is smaller, for example, let's say 6 and 5, then we start a loop from 5 till the end, and the first value, which is greater than both, becomes the solution. So 7 is the one which is greater than both, so it becomes the solution. So this is simple. So it's a doubly linked, double like nested loop, and that's how we have to do it. This is simple, but there is a big if and but there. We have to give a optimized solution that doesn't go up till n square. So what we have to do? I will just simply explain by taking the example. So example, the query. I'll take the query list first. We have 0, 1, we have 0, 3, we have 2, 4, 3, 4, 2, 4, 3, 4, we have 2, 2 as well. I also pull up the heights list. So heights list is 648527. 648527. So the first thing we will do is we'll create a list, basically list, or we can say kind of stack of, or whatever. You can just simply say it to be a sorted list of this query. So why we are sorting this query? First of all, what we'll do is we'll take we'll create a list. It will have 0, 1, and the index of this query. What is the index of this query? The index of this query is 0. Okay, then we'll take this query and we'll take the index as well. Okay, so again we'll have 2, 4, 2. We are also taking the index of the query within the query. So 2, 2, this is 4. This becomes like this. This is, I hope, understandable. Now next up, what we have to do, based on the first two index, we have to sort this whole query based on the first two index. Based on the first two index, whichever is the greater value in the first two index, we have to sort this whole queue list or this whole list based on that. So what it makes this to happen, I will just quickly erase the first part so that, okay, s- the maximum size of the eraser strange, but okay, this is just the job. This gets the job done. So what we are going to do next is we are going to sort this queue. So uh, so what this becomes is this becomes what is the greatest amongst the first two? 2, 4, 3, 4, and 2, 2. So like let's say since 2, 4 is first, we'll take 2, 4, 2. Okay. The next up we have 3, 4, 3. Next up we have 0, 3, 0, 3, 1. And we have uh, 2, 2, 4. And we have 0, 1, 0. So I have basically sorted in reverse order, but we have to, like, let's say this is the start, this is the start, and this is the end. Okay. Uh, I will start from the back of this sorted list, or we can even sort it in the opposite order. But yeah, we are basically starting from the maximum side. That's what I meant to say. Now, this is a simple thing which we understood. I will just remove all this. How to remove it in chunk? Hmm. So I guess I removed one more thing. That was 242343031, and we have one more query, that is, we have two more queries. One is 22 and 01. 22, 22 is at 5, and we have 010. So these are the queries. Now, next of what we have to do is we have to start iterating from the back of heights. So this is going to be an interesting point. We have to start iterating from the back of heights, and we have to maintain a monotonic stack. For example, it should always it should always be decreasing, strictly decreasing. It cannot be increasing. So what happens? Why I'm saying this? So like let's say 6485, we have 648527. So this is a screen that will make you understand discussion. Okay, so what we do is we start from the back. We'll also write the numbering 0 1 2 3 4 5. We start from the back of heights. Okay, we start from the back of heights. We see that the stack is empty. We simply put, if it is empty, we put the element we have 5. Okay, now we see that the index 5 is in. Then we start, then we create a while loop. Okay, then we create a while loop on this query list. Okay, from the back. So we see that the maximum among first two is 2 4. Okay, so maximum among the first four is 2 4, which is not equal to 5. So there's no issue. We'll just simply go to the next in the outer loop. This, like let's say we have a for loop, or we have a for from the behind of this heights array. So in the outer loop, we'll again go to this element, the second last element, 4. So we'll check whether the top of a stack has the index 5. So heights of 5, that is 7, is it greater than the current value in the heights? Yes, it is greater. So we'll just simply put 4 here. Okay. Now, in the same iteration, we'll start a while loop that till the max of the query, or the back of the query, which is sorted query, is equal to the uh, array, or the current I which we are considering, the current I in the heights. If it is equal to that, then we have to basically evaluate that particular query. So you have to understand this point very clearly, that we are moving backward from the back to front uh, in the heights array, and we are also evaluating any query that has the maximum index, or that has the rightmost index, either Bob or Alice, whoever is present at the rightmost index. If the rightmost index is equal to the current element, if the rightmost index in the query is equal to the current element which we are considering, then we have to basically finish evaluating that query. So what we'll do is, so we see the maximum of 2 4 is equal to the current I which we are trying to take. Okay, so if that is the case, first we'll check that whether the height at 4, that is 2, is greater than both or not. Whether the height at 4 is greater than both the height or not. Like for example, 2 4, the height at 2 is 8. The height at 4 is 2. So we clearly see that 2 is not greater than 8. So this never becomes an answer. Okay, but again here we see another tricky part. Like what we have to do is we have to perform a binary search. Okay, a binary search on this particular stack which we have. See, I know, like you'll have to digest it. So basically we are maintaining a monotonic stack from the back of this from the back of the heights array. We are starting from 7, then we'll go to 2, 5, 8, 4, 6. We are starting from the back, and at the same time we are also evaluating any query which has the rightmost index or the greater index uh, as same as the current I which we are considering. We are not considering the third index in the query, the third element in the list, because it is anyways just the position of the query in the original query list. I hope you remember that we initially had a different query. We saved it along with its index, and then we sorted it based on the first two elements in the list. So similarly, the same thing we are doing here, but the thing is we are uh, like we are not considering the third element because it is a position. So we are just considering the index where both of the person Bob and Alice are present. Okay, so that's the thing. So what we'll do is, so for example, so we see that 8, like 2, in 2 and 4 we see that 4 is not the element which has the greater height compared to these two. So this is not going to be in the answer. Okay, so answer will not be having 4, or answer will not be having the first index as 4. So one more thing we have to keep in mind: initially we have created a answer list which has -1 in everything. Okay, -1, and how many -1? Till the length of whatever there is in query, because for each query we have to give an answer, so all of them will have -1. The reason for having -1 is that, let's say, there can be a situation where both Bob and Alice cannot meet even. For example, in this query itself, in 2 and 4 we see like 8, 2, 8 and 2, there is no right element where they both can move and meet, because 7 is having height smaller than 8, so there is no right element there where they both can move and meet. Okay, so that is there. So how will we find it? We first see that 4 is not the solution. Then on the remaining elements, we perform a binary search to find the first highest element. How do we do it? We take in low, like let's say in low we take 4, in high we take 5. Okay, or we can do one more thing. In low we will take 0. Okay, and in high we'll take 1. Okay, so what we'll do is we'll find the middle element. Middle element will be mid uh, mid equals to low plus high by 2. Okay, so 0 plus 1 will anyway become 0. Okay, by 2 will become 0. So now what we'll do is uh, we are maintaining a stack in this order. So this is the first element, this is the second element. So first element will become 0, that is 5. So stacks 0 is 5, right? So height, we'll check height of stack 0, whether the height of the first index, is it greater than is it greater than both is it greater than both the elements in the query? Is it greater than 2? Is it greater than 4? We are first checking whether the height at the mid, is it greater than both the query. If it is greater than both the query, if it is not greater than both the query, then simply what we should do, like let's say if it is smaller, okay, let's say if it is smaller, then what we have to do, we have to move to the so I'll explain, like we need more elements. I will explain how to sort this or how to find this in subsequent explanation, but currently what you have to understand is like how we are evaluating it. So okay, I'll first iterate all the elements. Okay, so I'll explain how to perform the binary search. I will definitely explain. So let's see what happens if 5 comes in. 5 comes in. So we'll check whether the element at 5, is it greater than 2. Yeah, it is greater than 2. So we'll pop this 4 and we'll add 3, the element of 5 over here. We didn't pop 7 because 7 is greater than 5. So it has to be strictly decreasing, right? So 5, 3. Now we have 8. Now 8 is an interesting thing because 8 is greater than 3 and greater than the height at 3 and greater than the height at 5. So both of them are popped, and we simply append the index of 8, that is 2. And so why are we doing this? The major thing which we need to understand is, now 4 will come, just since 4 is smaller than 8, so we'll append its index. Now 6 will come, since 6 is greater than 4, so 1 will be omitted, and we'll just simply add 0 over here. Okay, so this is something which is what we want. So why are we doing this? Now major question is, why are we doing this? I will just simply remove some chunk from this, so that, and I will also remove this part. So what we are doing here is, so from the 648527, what exactly are we doing? From the 648527, what we are doing is, we are moving from backward, and we are storing only the current maximum. So what happens is, 7 is the current, is like, let's say if there is a query that exists up till 5, this index here is 5, up till 5, so it will, the the 7 can be maximum. Like, let's say then we append 2, it's 4. Okay, so if we have a query whose maximum index is 4, then 2 can be maximum, right? Like, let's say both the heights, previous heights were, I'm just taking, assuming it to be -5 and -4. Okay, so 2 can be the maximum for both of them, right? 2 can be maximum for both of them. Okay, so if it is smaller, then we are appending in the stack. But let's say 5 comes. Okay, 5 comes. So here we have evaluated all the query whose maximum or rightmost index is 4. Okay, so one thing you have to keep in mind, that is done. Now 5 comes. This index is 3. Now we are maintaining. Now we have to like, we have to evaluate any query whose maximum index is 3. Okay, any query whose maximum index is 3. So 5, how now you have to understand why 2 is not useful and 7 is useful. So like, let's say 6 comes, okay, or let's say 4 comes once. The maximum height on the left side is 4. Like, let's say 3 4 were the heights of Bob's and Alice. So uh, like 5 is a solution. Okay, because 5 is greater than both 3 and 4. Okay, and 5 is a solution. Like, but let's say if it comes 6 and 4, 6 and 4 is the ones, the query, then 5 is not the solution, because 5 is smaller than 6. 5 here is smaller than 6, so 5 is not the solution. But if 5 is not the solution, then there is no way that 2 can be solution, because 2 is anyways smaller than 5. Okay, but 7 is greater than 5, and 7 can be a solution. So that's what we see here. 7 is greater than 6 and 4, so we see that 7 is a solution to this question. So 6 4, like, let's say if Alice is at some building with height 6, Bob is at some building with height 4, so they both can move to the right, and the answer can be 7. So you understood why it has to be strictly decreasing. So if 2 is not useful itself, 2 will not be useful, because on the top of 2 will have an element which is greater than 2. So if there is no query which will want to meet at 2, because they will already meet at 5. Okay, they will already meet at 5. So, and index doesn't play a role, because we have evaluated all the query which has index as close to 2. Like, there can be a case where 5 cannot be a solution, but that can only be the case if the index in the query is greater than the index of 5. Okay, so you have to understand this. So there are few points you have to remember here. We took a query, we appended the index of that query in the queries 2D array. We appended it, we sorted based on the greater element, we sorted based on the greater index amongst the index of Bob's and Alice. Okay, we sorted in that way. Then we created a monotonic stack from the back of heights. Okay, 7 2, I'm not adding the index, we have to add the index. 7, 2. When 5 came, we have removed 2, 5. Then when 8 came, we removed everything. 8 entered. Then 4 entered. Then when 6 came, 4 was removed, 6 entered. So we are basically maintaining a monotonic stack from the back, and we are evaluating any query which has the maximum index or the rightmost index same as the current I in the heights. So we have to keep this in mind. Now this is to be implemented, but we have to keep one thing in mind. We have to see how we are performing the binary search. Okay, so like let's say from the same example, since we are maintaining it in list, from the same example we are maintaining a list like this, like 7, 4, 3, okay, 2, 1. Okay, now we have to find the and how was it originally present in the list? How was it originally present in the heights list? I will tell you how was it present. So it was present like this: 1, 2, 3, 4, 7. How did it become opposite? Because you remember in the heights we are traversing from the back, okay, from the last we are traversing, so it became in the reverse order. So you have to remember that it has became in reverse order. So we have it in this way. Now what we have to do is, this is the zeroth index in stack, this is the fifth index in the stack. Okay, so you have to keep in mind that this is the zeroth index, this is the fifth index. So what we have to do here is, I will quickly visit my solution because it basically has, so low will put at 0 and high will put as the length of stack minus 1. Okay, so we'll put low as 0, stack's length here is 5, so high will become 5 minus 1, 4. Okay, what is the mid? Mid will become, we know in the binary search, mid becomes 0 plus 4 by 2, so it becomes 2. So we are pointing to this element. Okay, so like let's say the height at 2, I will mention 0, 2, 3, 4. The height at 2 is greater than the maximum height in the query. Okay, so wherever Alice and Bob are, the maximum height for them is 3. So height at 2 is 3. Okay, so that becomes the solution, that becomes in the answer. We have, since in the query we also have the index of the original placed position of the query, so -1, -1, -1. So we, like let's say the query was present at fourth position, or so we'll put the answer as the index of 3. So index, so you also have to remember that this is whatever we are putting in the stack, it is not the value of the height, we are putting the index of the height. Okay, so we have to, this is something which initially everyone gets confused. Stacks are mostly, all the questions based on stacks are mostly saving the index, though the comparison and everything are done on the value of that index, but we in the stack we are maintaining the index in most of the cases. That is something you have to remember. So the answer, since it was present at the fourth position, the answer becomes 3. But what happens if the maximum height for Alice and Bob, the maximum height was greater than 3, or greater than the height at index 3, maximum height, so greater. So we are maintaining a monotonic stack. So since it is greater, so we have to move to this side. Okay, in the stack we have to move to the 0th side. Okay, so what we'll do is, so where this was low, this was high, we have to move to this side. So again, to find the mid element in this section, we have to reduce height. Simple. So height will high, sorry, not height. High will become a mid minus 1. Mid minus 1. This is where we have. Okay. So this will become high. Simple as that. But so how, in this also you can understand that in original heights array, if it was greater, if it was like, let's say the element at the current index was greater, the height at the current index was the, and while performing the binary search, if the mid, the height at the mid index was greater, then what we would have done, we would have done on the right side, right? We would search in the right side, assuming they are sorted, we would have searched on the right side. So that's what we'll do here. We'll move to the this side. Okay, for if it didn't match, we'll move to the greater indexes, because they can only move right, they cannot do move left. So we are searching from this side, they can only move right. Okay, both Bob's and Alice. Similarly, if the, so what we knew, if the height at the mid element is greater, okay, or if it is smaller than the maximum of the buildings of Bob's and Alice, then we have to put high equals to mid minus 1. Similarly, if it is smaller, then we'll have to, not only smaller, even if it is greater, like let's say height at 3 is equal or greater, like let's say height at 3, whatever was the index given for Alice and Bob, like let's say 0 and 1. If height at 3 was greater than both of them, okay, was greater than 0 and 1, both of them, even then we have to move to the left, then we have to move to this side, then also we have to move to this side. Why? Because there can be a scenario where the index before 3 also has a greater value, so we have to find that as well. So in that case, low becomes low equals to mid plus 1. Okay, so you have to understand this, even if the height at 3 is greater, okay, even then we have to move to this side, because there can be a scenario, there is an index which has a greater height than the buildings of Bob's and Alice, and its index is even lesser than 3. So basically what will it mean? It will mean, from this question, it will mean कि if this was mid, where we saw that they are having, they can meet, but still we have to search on this side, in the stack on the index, we have to search on this side whether there is a height that is greater than both height of the buildings of Bob's and Alice, and it is present before 2. So you have to understand this as well. Okay, so this is what I have performed over here, and every time you have performed the operation, the the last of the query you have to remove. Okay, we are removing it so that we can uh, directly access the last element, and it is giving the current current query which is to be considered. So you can see in the for I in range of length of heights, we are iterating from the back, we are maintaining. Every time we get a solution for a query, we are popping that query. And if the current I is, if the maximum of the both the indexes in the query is equal to the current element which is considered in the heights, then till we are popping from the sorted queue, till till all the elements with that index is considered. For example, what I meant is, like, there are 2 4, there are 3 4. Okay, so in the stack, whenever we pushed 5, we pushed 4. So when 4 came in, so every query which has maximum height or maximum index or the rightmost index, either of Bob or of Alice, whosoever is standing on the right, the maximum index is 4. So we have to evaluate all the queries which has 4 as the maximum index. So that's why we have a while loop inside this. So every time we evaluate an answer for a query, we are popping that answer we are popping the our topmost element from the list or from the sorted list. So that's what we are doing. So this is, I'm pretty sure this is a little tricky. You need to rewatch it, but I've also provided a solution. I've submitted my solution, so you can also, I'll put it in the description below. You can also search and see the textual description of what I have done here. And it ran, I in the, like, after submitting it, I had to see the hints as well. You can try attempting it, seeing the hints as well, and then see the answer. So yeah, that's there. I know it was complicated. I took couple of days to figure this out, and there are many ways to solve this. I saw in the solution they have several things, several ways to solve this which you can look into, but I took hints, and after spending couple of days with the with the question, I was able to understand it how to do, and there were many corrections, many things to be corrected. But yeah, this is a beautiful question if you're able to solve it. So please make sure to stick to the solution, and please like, subscribe, comment, share, and yep, thanks a lot. Happy coding. See you in the next video.